All right, today we're going to talk about relating temperature to energy transfer. Now, when two objects that are at different temperatures are touching, energy is going to be transferred from one to the other. It's just like if I touch someone on the shoulder and I'm hotter and they're cooler, there's going to be an energy transfer because we're at two different temperatures, so energy starts trying to equalize out. Now, the feeling associated with temperature difference results from energy transfer. So when I touch somebody's shoulder and they feel hot or they feel cold, that's a result of energy transfer. Now, temperature changes indicate an energy transfer, which we've already discussed, and the energy transferred between the particles of two objects because of the temperature difference between the two objects is called heat. And what's happening is when you have two objects that are touching one another, the temperature wants to equalize and be the same. So it's transferring, trying to get you to the same temperature. This transfer of energy is always from something at a higher temperature to something at a lower temperature. So that's how the energy how it moves. It goes from the higher temperature to the lower temperature. Now, there are three ways that heat energy can be transferred. The first one is conduction. The second one is convection. The third one is radiation. And we're going to talk about all three of these more in depth. Conduction occurs between objects in direct contact. That means they're touching one another. An example, holding a hot cup of coffee or a cold glass of tea. If you're holding a hot cup of coffee, the energy is transferring from the cup of coffee to your hand. It's making your hand feel hot. Okay? If you're holding a cold glass of tea, your hand is the higher temperature, so energy is transferring from your hand to the glass of tea, which is going to cause the ice to melt, and it's going to make your hand feel cold. Now, convection. Convection results from the movement of warm fluids. Now, this can be air or liquids. Fluids mean just things that can move more freely, and so that can be air or liquids. One rule is that hot air is going to rise. So in a room, hot air rises, cool air sinks. That's why you never want the top bunk at camp in the summertime because it's going to be really hot up there. And convection is possible only in fluids. Okay, and like I said, most fluids are liquids or gases. Radiation is the transfer of energy by electromagnetic waves. So this does not require physical contact between objects, okay? This is just a transfer of electromagnetic waves, which we talked about in a couple of videos ago. Electromagnetic waves are a lot of times associated to light. So this is the only method of energy transfer that can take place in a vacuum, such as outer space. In outer space, conduction and convection cannot occur, but radiation can. Much of the energy we receive from the sun is transferred by radiation. So when we're feeling the warmth of the sun when we're standing outside, that's an energy transfer by radiation. Now, just a couple more things. We have conductors and insulators. Conductor is a material through which energy can be easily transferred as heat. And we've talked about this before. They're always good energy conductors. And one of the reasons we make cooking pans out of metal is because metals are good conductors, and so they transfer heat easily. Metals are good conductors of heat. Non-metals are bad conductors of heat, and we've discussed this before. And remember we've talked about the example of an electric wire from your TV to the outlet. Inside the inside the cord are metal wires because they can actually conduct the electricity. On the outside is a plastic tubing because that's a non-metal and it helps absorb the heat so that we don't burn ourselves when we're unplugging or plugging in our TV. Now, an insulator is a material through which energy is not easily transferred as heat, which would be like the plastic on the outside of the electric cord. Insulators are bad energy conductors. They do not conduct energy well. Nonmetals are good insulators of heat. And metals are bad insulators of heat. So metal will transfer heat easily, but it doesn't keep it there. Insulators, we use insulated cups for coffee and things like that so they stay hot. Or we use insulated cups for even cool drinks in the summertime so they'll stay cool. It helps to keep the temperature more constant and more consistent. All right, now let's go ahead and go to the next little set of notes. Okay, specific heat is describes how much energy is required to raise an object's temperature. And so specific heat tells us how much energy we're going to need to raise something's temperature. And right now, we're going to go ahead and do a little bit of practice. I'm going to give you one practice problem, and then you're going to do some practice on your own. Now, we have two more things to talk about, and they're the law of thermodynamics. There's the first law and the second law that we're going to discuss today. Now, the first law of thermodynamics says the total energy used in any process is conserved, whether that energy is transferred as a result of work, heat, or both. So the first law of thermodynamics is just that total energy is conserved, which actually goes right along with the law of conservation of energy. Now, the second law of thermodynamics says that the energy transferred as heat always moves from an object at a higher temperature to an object at a lower temperature. And this is a reminder that a disorder of a system tends to increase. If things are left by themselves, they're just automatically going to become more disorderly. If you move out of your house and you never come back and cut the grass, you never come back and paint the outside of the house, eventually that house is going to look really, really bad and really, really rough. And it's because when a system is left to itself, it goes from a higher energy state to a lower energy state. And so this also has to do with heat and energy. All right, now this completes our notes, so I'd like you to go ahead and summarize. I would like you to write a tweet summary, which means you need 140 characters or less to describe this video. Have a great evening, and I'll see you in class.